one of the key parts of key events is that they are predictable. You can actually monitor many of the key events and be able to show that the probability of that key event occurring. If you take the financial meltdown of last year, that would be an example. That many of the banks were giving loans to people where if the interest rates went up over a very small amount, then there was a high probability those people would not have the financial resources to sustain those loans. So the key event was when the interest rates started climbing, all of a sudden a lot of these mortgages began to go into default. And again, that was a key event. But frankly, that's one we should have been predicting all along.
Well, Jim, is the issue understanding the key events and having a way to deal with those key events like hurricanes and tornadoes? They happen periodically year after year after year. Or is it the issue that we're trying to predict when the next hurricane is going to be or when the next financial meltdown is going to be?
It's the former, because we know that hurricanes will occur, for example. We know the key events will cause problems. The important aspect is to look at each process and understand what are the few in number key events that could have the biggest impact on that process. And then you begin to monitor those key events, preparing and making your process more adaptable to changes.
Okay, well, let's go to this next corollary. Process variation arises from these initial conditions, the environment we talked about, the resources. But what's this about incompatible product and service features? Incompatible to who or what?
Yes. In our previous slides, we talked extensively about the various initial conditions, and we're not going to really recover that ground today. The key is to look at a second major factor other than purely the environmental and initial conditions, and that is the features of the product or service. Now, what that is that we want that any process is designed to handle what I call the sweet spot. And the sweet spot to me is given a certain set of conditions of what you're asked to do with that process that it's been designed to do. So if we were to use a sewing example, every sewing machine has tolerances of how thick or thin it is able to operate at its peak efficiency. When the material that you're asked to sew gets either thicker or thinner than that optimal, then it loses its ability to operate as effectively. So one of the key things we have to do in processes is understand the process capabilities. And they're basically three categories. One is the adept capability or the sweet spot. The things the process was designed to do, the processes, and it's very well. Then there's the problematical capability, meaning it can process it, but it's not going to do efficiently. So back to my sewing example, if I have very thick material, then I'm going to have many more quality problems and I'm going to have lower productivity because the machine was not set up to do those on. And finally, there's impractical capabilities. Above a certain amount of thickness, I could not even put my cloth into a machine. And so there are physical limits too.
So it's important to understand what our process capabilities are, and if we take on customers or products or services that don't match those process capabilities, even if we get additional revenue, we might not make very much money doing it because it doesn't match our sweet spot.
Exactly. And also we run the risk of quality and a lot of hidden factors that will not show up directly as a result of that decision. And that's what makes it insidious.
Okay. And then this last slide in this section we want to talk about is feature costing. What is a feature? Why should I cost that way? Who cares? Talk to me about this.
Yes, let's start off by remembering that this graph we saw in the previous slides, the previous day, and that was that there exists a range of what we'll call the sweet spot or the ideal conditions for a process. And therefore, in this example, this is a machine finishing for steel. That if we asked it to go from a certain range of granularity to another, that it operates fairly effectively within each of those. It also said that there's several ways of doing it, several processes that you could use to accomplish that. Now, once you get to a certain very fine finish, then the process can accomplish that, but it becomes very expensive, and again, the quality problems increase dramatically. And then there's finally a certain level of fine finish that beyond which we're incapable, given the processes that we're looking at, that would be incapable of performing those. So the concept here is, if we return to our previous discussion, that every process has a range that is very good at, sweet spot, one that it can do, but at a tremendous cost, and one that you cannot go beyond, then it's important for management to manage and understand those because when they take on new work, the potential problems that could be created by that new work, if it's outside the sweet spot, can be very significant.
So this sounds like this is critical not only for operations, but also for marketing and for research and development. Marketing needs to make sure that they sell to customers that are in their sweet spot, and research and development needs to make sure they develop products and services within their sweet spot, because if they don't, you could generate more revenue, but not necessarily more profit.
And also product design. Because if the product designers were able to design this where it needed a slightly less level of finish, then the cost could go down dramatically. So often what the designers are doing is they're trying their best to meet the specifications, but without a feedback on the processes, their capacity, which we'll get into on a later date, and other factors such as the ability of that process to function properly, then we can make radically different design considerations, which today we tend to make independently of each other, and then try to make it work when we go into production.
So your homework assignment is to go find your sweet spot and communicate that to research and development, design and marketing, so that everybody's on the same page working to maximize that sweet spot or changing your sweet spot. This is John Antos and my good friend Jim Brimson. We thank you for watching our tape on business process management, and we look forward to having you come back and see our next video on business process laws. This is John Antos and my good friend Jim Brimson, and we welcome you back to our series on business process management. We're going to discuss the third law of business process management today, which talks about that interdependence of processes. So Jim, aren't we all an island? Why do we care about these other people? You know, if I take care of my department and my processes, who cares about anyone else?
Well, that's clearly one of the most important aspects of business process management that has been discussed up to this point. We talk very much about being able to create flowcharts to describe processes and use other techniques. But one of the interesting parts of this interdynamic dependency of processes is that there's actually two forms. One is what we'll call the hierarchical, where there's master and sub-processes that exist. That has not been as well developed in process theory. Then, of course, there's the flow, or the precedence of action, and that is one, again, which has received considerable attention in the literature up to this point in time.
Okay.